all this work is for. And after doing these enough times, right, you're like, well, this is a lot of work just to find out that one number. Okay, but it is a method that works when you have some good numbers that are, whole or negative fractions. So we got -5 is 2 down 5. Giving you where to start, and then giving you slopes up 8 and over 5, up 8, over 5, and then from here, this is what allows us to think the equation. We already know from here, right, that the equation will start with y equals 8 over 5x. But now we know from the equation, from the graph, okay, it's going to cross at positive 3. Okay. So the question is, here. You still know the first part of the answer because the slope is given. So it's not y equals mx plus b is your answer, right? So they give you the m. All you're doing is trying to figure out, well, what is this line? Now, here's where reality kind of comes in down here on number 5 and 6. So we start like at -3, 1 right here. And then we go down 3, right 2. 1, 2, 3, over 2. And then again, 1, 2, 3, over 2. 3, over 2. And we draw with a straight edge. Right here. What is this point right here? Right? It's a decimal. It's something in between that you cannot for sure estimate. Is that -1 point or a -4.5, a -4.55, a -4.6? We can't say, well, it must be 0.5 because it kind of looks in the middle. I mean, you're graphing it by hand, so it's an estimation, right? And that's where we don't want to just estimate and say, well, that's good enough. Okay? We want to be very close and be exact. Okay? Just to take a little segue here, why does the precision matter so much? Okay? So you're going to be doing a project on decimals. That's the art. Let me find a good one for the math examples. You're going to be coming up with a picture of your own, right? That's going to be mostly straight lines. I'm in the math. I need to be in the art. Try the art. There we go. So let's say right here, all right, so here's where we're heading. So you can see this takes up about 215 equations to make this whole thing. And you'll notice the equations are a lot of decimals, right? And if we just say, well, we can just round these and just put it per whatever and it's going to be the same, you can see if we just change this and we just make it 3, just because, well, it looks like 3 and you start rounding things, it's going to start messing everything up. So you do need a certain level of precision, and that's why we're learning how to do this, is that at some point we can't just say, oh, it's close enough, it's fine. Especially like when we get here, see these diagonal lines, if we even take this and make it -6 instead of -6.05, right? And you can see now it's off by a little bit. It's obviously not correct because it doesn't fit perfectly. So we can't just say, well, -6.5 is the same as -6.55, because if you're actually trying to make something, make a picture electronically, or make some animation work, it has to be exactly precise. So just want to really beat that in on why we need to be exact here and not just say, it's this, it's pretty close, and that's fine. Okay, we want to be absolutely exact. But if we had to, we can estimate. We already know that this is going to be -3/2x. Right? And we could say this is -1, -2, -3, -3 point something. Right? You don't know for sure. I mean, if you're not sure at all, you can say maybe it might be in the middle and half, but maybe not. So this is a question mark. That's an estimation. We don't know that for sure. But when we do the formula, it'll actually be completely accurate. Same thing over here. Look at number 6. Start at -2, 4. Go down 6 and over 5. Down 6 over 5. Like that. And you do this. Same thing. Right here is some fraction. It doesn't go through one of the grids exactly. So the best you could do is write -6/5x, right? And then estimate, so like maybe 1.5. I mean, but that's an estimation. You can't tell exactly by looking at here if it's 1.5, 1.4, 1.6, 1.55. As you just saw on the Desmos, when you're actually creating something, that 0.5 or that 0.05 can make a difference of it looking good and looking bad. Okay, so precision is actually important. So let's go through some of the formula here. We'll just start with 6 since we're already here. That's a nice little thing to color code with. We have to plug in 3 numbers, right, into the formula. So the first one, this is x, 1. So that first number actually goes at the end. So this is x1. And we have y1, and we have m. So y1 right here, and we have slope, which is right here. So 3 numbers, plug it in, and it should come out to be the same. There we go. And one little note before we start, the negatives here, the minuses here, are not the same as the minuses here. So if there's 1 here, we have to have that no matter what. So we have y minus y1 4 equals the slope, -6/5, parentheses, x minus, and the x here is -2. So notice how it's minus -2. You got to have both of them there. And the goal now is to get down, solve this. We're trying to get y equals, so we're going to solve this so there's no parentheses and this -4 is not there anymore. And it should match or come very close to this, only the y-intercept is going to be an exact fraction. So we get the exact number. So here's where some of the, if you want to check on the calculator, you can. So we got -6/5x, just distributing, right? We got -6 times +2, Two negatives make a positive. So that's going to be minus 12 over 5. If you're not sure about that, check your calculator, but basically it's 6 times 2 and then over 5. 12 over 5. Okay. And then we can add 4 to both sides since this is negative. So we have y equals 6 over 5 x, and then we just need to figure out, well, what is this equal to? What's negative 12 over 5 plus 4? So if you want to put that in the calculator, or if you want to do common denominators and then, do it that way, you can. And what does it come out to? And you want it to be improper fraction. Yeah, always improper. To get the improper, hit the shift fraction button. I'll give you improper. What it comes out to, what do you get? I think it's 8 over 5. It's just not the technical, not point slope form, but yeah, solve, yes. Okay, so it turns out that this number that we estimated, it's really 8/5. And if you make that a decimal, it turns into, I think, 1.6. So we estimated at 1.5. We estimated at 1.5, but it's really 1.6. Okay? So good thing we did this form and not just rely on the graph, because we would have been off by a little bit. Now, in your final answer, you usually just leave the y-intercept as a fraction. We don't want to make it a decimal, mainly because of some numbers, some denominators give you repeating decimals, and you never want to have an answer with a repeating decimal in it. So that usually happens with 3s, some 6s, and then 9s. You'll get repeating decimals. So never have your y-intercept as a decimal, okay? Unless you need to go ahead and graph it. Okay? But up here on the original ones, like going back to like number 1, we can do the same old process, and it matches exactly. So we could do x, y, and m, right? -1. And as long as you plug them in correctly, the rest of it's pretty often easy. I guess the most common mistake I would see would be negatives. Like this double negative, realizing this minus sign does not count for this negative sign. You have to have the minus sign from the formula and the negative from the number you're actually plugging in. In other words, anytime you plug in a negative in the formula, once you simplify, it's going to be a positive. Because you plug in a negative right after a subtraction sign, so every single time it's going to be minus the negative, so it'll become a positive. And then here we'll just distribute -1x plus 1. Right? -1 times -1 gives you +1. And then subtract 5 on both sides. So we get -x, and 1 minus 5 is -4, which is the same y-intercept we got by looking at the graph. Only we did not have to graph it using this. Okay. So this is nice. It didn't take too long because they're nice small numbers. But again, what if this was the coordinate was -5.77, comma -342.458, and the slope was, -3.58. Right? You wouldn't be able to do that with a graph. And that's more realistic when you're dealing with money and you're dealing with real life things. They're not going to be these nice, easy numbers. You have to use a formula to get an accurate equation. Otherwise, you're just estimating and guessing every time, and that doesn't work very well for predictions. Okay, so yeah, we get the same answer on both of these. So as we check these, both these equations should be pretty much identical, except for the ones where you estimated, like on the bottom. Those might not be exact because one you estimated by looking at the graph, and the one on the right is going to be the exact answer, the more accurate answer. But the first four, those should come out to be exactly the same because you're just doing the same problem two different ways. Okay. So that's the rundown for the full process, and we're really just focusing on this part, okay? All of this. What we're going to do now is break it down into smaller steps just so we get good at each part and don't just get lost in the middle. So page 2, if you just flip it over, page 2, it's just going to practice the smaller pieces. So read the directions. Sometimes the directions are a quiz in themselves. Do you understand them? Do you know what you're supposed to do by reading this? Okay. So you write in point slope form. What is point slope form?
The y equals y minus y1 equals n, parentheses x minus x1 plus.
So you have to know what point slope form means in order to answer the question. So this is what your final answer will look like. Really, the only thing you need to do is simplify double negatives. It asks you for the point slope form. It just wants you to make it look like this and stop. That's all they want. So something like here. And if you like to highlight things like that, you can. Just make sure you put the right number in the right place, and then recall that when you plug in a negative, it's going to be minus a negative. So we'll have here y minus 1 equals 2 or 5, and then x minus a negative 5. Okay. The only thing you really need to simplify from here, and then you're finished, is that anytime you have a double negative, make it a positive. So basically, you're just practicing part 1 of what we did on the front. We're not doing the whole thing here, we're just practicing part 1. So once you get here, you have to know that this is your ending point because they asked for it in point slope form. So yeah, that's finished, and that's your final answer in point slope form. Okay. And this is the first step. This is step 1 on the front. It's just plugging in numbers correctly.
And the back is actually the bottom.
Now, trivial as this might seem, there's actually a lot of mistakes that could be made here. You can mess up on the double negative. You can accidentally switch x and y. Because x is first here, so you might accidentally put x first here instead of y. That kind of thing. So just be careful. Don't assume it's too easy to get wrong. Okay, now down here, you can see it's already in the point slope. And read the direction. What should your answer look like?
The actual equation.
Yeah, so this one says slope intercept form. So we got two formats, both with the word slope in it. One has a slope and the y-intercept. One has a slope and a point. So the slope intercept means slope and a y-intercept. So that means it should be, your answer should look like this, y equals mx plus b. So this is the step 2 and step 3 that you're practicing here. Right? So distribute with step 2. Okay? And then our numbers on the left. If it was -3, we added 3. If it was +2, we subtracted 2. Now it's that. And you may or may not need a calculator to help you fractions. The fractions are pretty simple. I urge you, especially at this point, if you have free range to use a calculator, that doesn't mean you use it for all the everything. You still know what half of 2 is, right? Half of 2 is 1, and then negative and positive is negative. Don't say to yourself, I need to plug every little calculation in a calculator because I have it. Use common sense. You know, if it's a half, you can take half the number without a calculator probably. Okay. That's step 1. I mean, that's the second step, right? That we just did. And then the third step was just to add and subtract the left numbers, -3, so add 3 to both sides. And 3 minus 1 is 2. So we're getting the answer, we're getting the y-intercept, which is +2, and we're not using a graph at all. Okay. So that's the idea. Go ahead and finish the fact side. Practice plugging everything in, check with someone. We want to catch any little mistakes right now before you start doing the whole problem from the end to end. And then you can go to the next page, and that's going to be the whole problem all the way through, just like we practiced on the front. You'll have to know how to plug everything in and make it point slope. And then do step 2 and 3, distribute and add subtract the number on the right. So the last page is kind of like the first page. We're just putting it all together. Do expect some fraction answers. And write your answers as fractions. Your y-intercept as fractions. Do not make them decimals. Okay? This will get easier as you do it, and you'll be doing an awful lot. You guys are going to come up with your own art project, your own picture that you want to make, right? And you're going to have to repeat this process several times, well, actually many times, in order to get the right equations of the lines to put in decimals, and then you have to do the domain of range to make sure they start and stop in the right place. So we're leading up to a nice project that's going to combine everything we've done so far. And as you can see, as we look at those examples, you know, it's very doable. Like, this is, you know, you can make these equations. These are all student created, so you can do it as well. You won't be able to do the circles and things like that. You'll have to pick something that has just straight lines, because circles are really algebra 2 and the curves. These curves you actually will know how to do by the end of algebra 1, which is parabolas. These circle shapes. If you only have like one, I can help you out with just one. Don't pick something that has so much. You also notice that a lot of these are just horizontal and straight vertical lines. So like x equals -8, that's just a, you know, it's just a vertical line. It's very small vertical lines. They don't all have to be these diagonals. Okay, you'll have a lot of vertical and straight lines that are very easy. Alright, so work on that. Do a few, check with someone to make sure you're doing it right. You're not gonna, and then you'll get some confidence, and then you can finish the rest on your own and then check at the end.